Hello guys, my name is Diego Pacheco and this is gonna be another Scala video. So this is gonna be the part 2 of my video about Scala 3, where we are taking a look in several features and characteristics of the language, right? So let's get started. So I just want to talk something about the previous video. We're gonna continue with generics, but before I went there, I want to talk about dependent functions. I just want to make one comment here, all right? What's going on here is that this function extract key, it receives an entry as a parameter and returns the key of the entry. And that signature here, all right, is exactly the return of this function here, right? So sometimes Scala can be a bit confusing, but what happens is like structure does not take parameters, right? And all of this is the return. And the return is we are returning a function. And if you look what the function we are returning, the function that we are returning receives an entry and returns the key of the entry. It's exactly what the extract key does. And that's why the implementation is we just return extract key. Because, and that's where you get the dependent function. All right? So that's the only thing I want to clarify. Now let's continue. So generics, that's also not new, was in Scala before. So here we have like the Python syntax in Scala 3. So we have a stack, which is the type A. In Java, normally we use T or O. In Scala, often we use A or B, but just a preference. Could be T here as well if you want. Then we have elements, which is a list of A, and we initialize as new. Then we're gonna have push, pick, and pop. So push, we receive A, and we return unit. All right, and we just use this operator to merge that element with the other elements on the list. So here we are adding that element on the list. Pick, we just return A. We don't take parameters, as you can see here. This is the same as doing something like this, right? And here we are doing dependency as well, right? So we're doing elements.head, right? So we are calling the head function on the elements. And then pop, we just return A. And again, we have the Python syntax where we're gonna get the current top, which is we do pick. And then from elements, we're gonna get the tail, right? And then we're gonna return current top, right? That's how we pop it. Here we initialize the stack, being stack of integers. We push 3 integers, and then I'm just playing with pop. At some point, you're gonna see, because we're calling pop so many times, we're gonna have an exception, because after a while the head gonna be empty, all right? And then we're gonna have issues here. That's what's going on. So going next, now let's talk about implicities. Like I said, implicits change on Scala 3. And now you have givens, right? That's the new way to do implicits. So let's say you have a case class here, which is a config. Then config has a port and a string, which is a URL. And then we have this method, sort of a rendering a website, and this rendering you're gonna receive a path. And we also want to receive implicitly config. And the second parenthesis that we have here is where we have the implicits, right? So we are using, we're saying using config. So if there is an implicit config object, gonna be used, right? And then we're gonna return a string. And here we just concatenating HTML with the render widget function. And if you look render widget, we also have config as implicit parameter, and here just doing items dot to string, but ideally what you want to do is to use the config object and get stuff there, right? So here we are defining a config object, and we're saying that the port is 880, and this is the URL, let's say. And then I need to confess, guys, this syntax is a bit weird for me, because you say given, and then you say the type, and here you say the value, right? So it's a bit strange, a bit like Java, but anyway. So you are saying, okay, given, I'm gonna declare implicit here, the type gonna be config, and the value is gonna be this value here, all right? And then if you wanna pass or not pass is up to you. If you don't wanna pass, like you see here, render website, I'm just passing a string, which is this path here. As you see, I'm not passing config, right? Because we have a given here. But if you want, you can do option 2, where you can do stuff like this, and you can say using config, and then you can explicitly pass the implicit, right, which now is called given, and that's all. You can run this, but there's much special about it, all right. But that's more or less implicits now, right? Given and extension. And yes, that changes imports, right? So let's say here I have an object, and then I have a class called TC, and then I have a value that is the instance of TC. And then I can create a given, right? Where the given is TC, the type, and the value is TC. And then I have a function f that receives a given and just prints the given. And then when you import something, right? In Scala, we always have these underscores in importing, mean import everything, but this will not import givens. So if you want to import givens, you need to say dot given to then import all the givens, right? And here are some samples of me importing A and B objects givens, all right? So going forward, so here we have a hello world, just showing that we can do that in one line now. We can do at main, and then def hello, and then equals. You see here I am omitting stuff like this, right? Which it could be this way, sort of a long syntax, all right? But this is not necessary. We can just short it to this way, and that you have the smallest hello world possible in Scala 3. Okay, that's also nice. Now we go to something else, which is called higher kinded types. This is not new. It's Scala 2.5 as far as I remember, and this is like generics of generics, right? So what if your generics have generics, right? I don't think you can do that in Java, but so let's say you have a trait here, which is collection, and I want to receive a generic type T, but then I can specify the generic of the generic, because what happens if T is a list, right? And in this case here, we are saying, well, T can be wherever, right? So I don't care about the second generic. And then there's two methods. That's ROP and there is first. In ROP, we receive a generic A, and we're gonna receive an instance of A by parameter, right? And we're gonna return a T of A. So the return type here is T of A. So meaning T, and then here wherever you pass by parameter, right? So imagine this is a list of integer, then you're gonna pass me here some integer, and I'm gonna return the list of integer for you. All right. So yeah, the generic of the generic. And here we have the method first, where I'm gonna receive B, and what I expect you pass me by parameter is like your T of B. So going back to my generic of the generic, right? Let's say you have a list of integer, so T is list and B is gonna be integer. Then I'm gonna return B, meaning I'm gonna return that int, the first int of that list of integers, right? So that's pretty much generics into the second level, right? So you have type and the type of the type, right? So that's what's going on here. So now let's implement that trait. We have a mutable variable called collection, and then we create a new collection because we're gonna do some inner classing here. And then we're saying, okay, this collection is for a list. So list is T, right? And then we're gonna wrap to say of A, and look how cool is this, guys. So we're saying it's a list, but because we add A and B here, we mean, well, it doesn't matter what kind of a list do you have. Could be a list of string, list of doubles, and it will work anyway, right? And then on implementation, we're saying, okay, so for wrap, we're just gonna create a list around your A, right? And for first, because I want to return the first element of the list, we will return b.head, because b is the list of b's here, right? And then I'm just gonna get the first element with head, right? If I want, we could say that a here is a string or int, and then we could narrow this down, right? But this is cool because then every level it specified the type even further, right? So the types they're getting specified all the way down in multiple layers, right? That's what's going on here. And then here you can see I'm doing some wrap with a string and also getting the first element. But let me run this, all right? So we see it works. And the cool thing about this, like I was saying, right, is it's generics in layers, right? So let me just change the variable names here. But now, like I could do stuff like this, right? And this will work, right? And we can also print then here, no problem. Just let me put a 2 here, and then you're gonna see that it works. Yeah, and I could go any type, right? And the reason why is because although here I said that the T type of the class is a list, I didn't set what A and B means, so it's still generic, right? So you can control different generics, like the class and the method level, right? So that's cool. That's really, really cool, and not new at all, right? But anyway, it's a cool stuff. So now we have something called high-level language, right? And again, this is not much Scala 3. It's Scala 2 as well. So here we have a main with a Scala 2 syntax, and we have a function double, where you're gonna pass a list of integers, and we're gonna get back a list of integers, right? And here what we will do is like create a buffer, and then we have a list buffer. And the difference between list and list buffer is list immutable and list buffer is immutable. And I like what Scala did, that buffer means mutable, right? Every time you see buffer is mutable. So list buffer mutable, just list immutable, right? That's a nice naming convention right there. Then what we are doing is for each here, we are going all looping over all the integers that you're gonna pass to us in ints, and put an I, and then we're just gonna add on buffer, right? And we're gonna do is get that number and multiply by 2, and that's what's going on. And then we're gonna transform that buff into a list. And the reason why we're doing that is because we said that we would return a list here, not a list buffer, and then this is immutable again, right? So you see here 1 to 6, and we just run it. We just get all the numbers multiplied by 2, right? So 1 plus 1 multiplied by 1, 2, 2 by 2, 4, 4 by 4, sorry, 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, 10, 12, all right? Because 6 by 2 is 12, 5 by 2 is 10, 4 by 2 is 8, and so on and on, right? But Scala is nice, right? This code is kind of a short, but we can do even shorter, because you could do something like here we just want to print it, right? So we really don't care much about variables, but you could do something like, okay, so we're gonna create a list from 1, 2, 3, 4, 5, 6, and then on this list I want to apply a map, and what I want to do is get the current element and multiply by 2, right? And in that case, We go there, and we get exactly the same output, but one line of code, right? So that's just showing how Scala is cool, right? And this is not Scala 3, Scala 2 can do it as well, right? Now, implicit conversions, we were talking about given, all right? So let me give you another given example, right? So have a main class here on a Scala 3 way with a main annotation and a function that returns unit. And what we're gonna do is add a method. We're gonna add a conversion, all right, a method, and we're gonna be able to convert strings into integer. So what we do? We do a given conversion, right? And if you look, conversion, right, is not really a thing. As see here, I'm trying to open. So guys, see, this is not a type, right? I cannot open at all. It's just a name. I could name it whatever I want, right? Like conversion X still would work. No, I guess not. Yeah, I guess not. So here, yeah, I don't think I just have the type. I think that's yeah. But basically, we're saying two types, and I want to convert from string to integer. That's what I want to do. I want to convert from string to integer, and then you say with. All right. So you say, okay, you're gonna do a conversion. It must be from a string to integer, and what's gonna happen is this. In apply means, well, in your method, when you receive a string, you must return an integer. That's the types that we sort of are gonna intercept. So one way you could think this is a interceptor, like AOP, but this is like code driven. It's not like runtime weaving or stuff like that. So you have a compiler in your side checking things, okay? And then, okay, so we're doing a conversion from string to integer, and we're gonna receive a string, and we're gonna return an integer. And the implementation is very simple. We're just gonna rely on integer.parseInt and pass the string. And now, let's say you have a function called +1, where you just pass an integer, right? And here you see I'm omitting the type, but I could say we're also gonna return an int. That also works, right? But it's not necessary. Scala can figure out. And we just say, okay, whatever you send to me, I'm gonna do +1. And then look this. I can do +1 with 1 in a string. So this should not work because I'm expecting an integer, not a string, right? So, and if I remove the given, you see that this becomes a problem right away because +1 does not expect strings. It expects integers, right? But because we have the given, which again, this existed before in Scala, the implicit conversions, but now this is the new way to do it, right? So it's just making a bit more concise. Okay, the next one is a lazy list. You guys might see this in like Apache Spark, where you do a bunch of operations, but the operations are actually not happening, and just at the end, the operations are really being computed. And that's useful when you have like infinite collections or huge ranges of data and stuff like that, right? And here we have a lazy list, right? And that's the magic. We use this type called lazy list. And then I want to create a range. And this range is going to be one from the maximum integer value, right? And that's realized to Java maximum integer value, right? It's 231. So it's quite big. And I don't want to be computing this yet. And this will not happen because it's a lazy list. So now we're going to change a lot of functions like, oh, I want to take 1. Now I want to take 5 from this list. And then I want to do a mapping. I want to increment 1 in all this list. And now I want to get the first 10 elements. And that for first 10 elements, I want to print it once. and then I want to go over all that 10 elements and print whatever I got there. Just here that actually the computation happens, right? Just write it to the end, right? So this is cool because let me run it. What's going on? There you go, right? So this not computed is this first print, right? And here on the for each, then we actually computing, right? So this is pretty good. It can improve performance. It's really great technique. Now that's something I kind of have mixed feelings, but again, it's all about types, right? You can do a match in the types. You can do types matching, right? So let's say I have a type, which again is an alias, right? And I'm saying that I'm gonna have element is the name of the type, and that alias has a generic called x, and I don't know what value of x gonna be, and it will depend on what you pass to me. So this is a bit tricky. You pass me one type and you're gonna get another type, right? So you do a pattern matching here, right, on the type, and then we say, okay, if x is a string, I want you to use char. If x is an array of anything that I'm calling t, I want that t, right? So if it's an array of integer, I want the integer. If it's an array of a double, I want a double, right? If it's an iteratable of t, which can be, again, string, double, integer, whatever, I want that whatever as well. So now, this allows you to do some sort of factory or container or wrapper. It's like you do a factory on types, right? So that's kind of where we're going. And then I have C here, this is the name of my variable, and I'm saying this is gonna be element of string, right? And then actually what's gonna happen is I'm gonna pass on char, because the string leads to char, right? So that's what's going on. And here I'm saying the element is gonna be an array of integer, and an array of integer leads to t, and t in this case is gonna be int, and this is gonna be 1. So I can run this, and we can see my char and my integer there. So that's match types. Now here, it's just like implementing a map, my own map. If you wanna ever wonder how you do your own map, right? So it's my map, and then I receive a as parameter, as a generic type here, and the parameter of the map is a function, and this function is called f. And this function is a function which receives an integer and returns an a, and a is this generic here. And the second argument is a list of integers in this case. But it could be a list of a as well, right? And here I return a list of a's. And the implementation is, okay, I'm gonna do a for on the list. It's called xs, right? For comprehension here. And just gonna yield, I'm gonna call your function f, you pass me as parameter, passing x to you, right? And that's it. Very easy to do a map, one line. Then we have a list of integers, and I have my implementation here, my map, and I just, my implementation gonna be underscore multiply by 2, right? And I'm gonna pass the integers, and then we have the result. And here's a second implementation, more towards generic, because I had some stuff hard-coded here, like my ints, right? And then my map generic, I'm defining two generic types, A and B. I receive a function that I go from A to B, right? From B to a list of B's, and I return a list of A's, right? And the implementation is exactly the same. And then here we say that our map generic is any, as A, and as B is int. So we have here our list of ints, and the implementation is, well, I wanna just add 1 on those, and here multiply by 2, it double, and here increment by 1. And then I can run, and you can see it works. It's just working fine. Okay. The next one is about named parameters. I think I showed that before. I just wanted to be explicit. I felt like this is definitely copied from Python. And to be clear, I think this is pretty cool. Where when you call a function or a constructor or a case class or an object or whatever, you can name the parameters, right? And that's cool because when you read the code, you know exactly what's going on. I really like this feature. I really, really do. It's cool. It's really cool. I like this. All right. It's nice. Right. It's something like you definitely could omit it. Like for instance, like here, I do it this way, right? And then okay, it's the second position, right? But having the name here is just much better. And one other feature we have here is about default parameters as well, right? So for instance, I think you guys saw it when I was typing, right? But I can do stuff like this, and this works. And I just have one implementation. I don't need to override this to have 2 functions, right? And the reason why is here we have a default value. And because we have a default value, we don't need to pass that, right? So default values are cool because you don't need to do a bunch of overloadings like we would do in Java, right? So it's so much less code, and it's cool. It's cool, right? Here just printing, but I can run this code. There you go, and it works. I think that's it for this video. Next video, I'm gonna do the part 3. We still have lots of things to go over it, right? I hope you guys like it. See you next time. Take care. Cheers.